Okay, good afternoon, everyone. I'm Zhonghan from Berkeley Sky Computing Lab.
I'm Waylon, also from Sky Computing Lab.
So at last year's RAISE Summit, we introduced a first release of the system, SkyPilot, which is a system for running AI on any cloud. And in the last 9 to 10 months or so, we've seen a lot of organizations adopt SkyPilot for generative AI, large language models, and other compute-intensive jobs. So today in this talk, we will give you updates on all of these new developments, and I will give the first part of the talk, and Waylon will give an on-stage demo later. Let's get started. So the core problem we are trying to solve is that running AI on the cloud is too difficult and expensive. Through building SkyPilot, we want to make it dramatically simpler and more cost-effective. Before we dive into the solutions, let's look at the problems a little bit more. So imagine we are an AI user trying to run jobs on the cloud. Well, the first thing we have to do is to pick among many clouds, regions, zones, and accelerators. And there are like hundreds, if not thousands, of choices to work through, which is a huge hurdle. Then the user goes to the chosen cloud and region to try to provision an instance. But in today's GPU shortage, this can frequently fail due to resource unavailability. And let's say an instance has finally been provisioned, the user then has to perform data transfer, such as downloading or mounting an object storage bucket into the instance. The user also has to set up the instance, such as installing packages. And there's much more complexity if the user wants to scale, right? For example, doing hyperparameter tuning containing many jobs to be managed and to be scheduled. The user may also want to scale out to multiple nodes in a cluster, and this requires all of the previous steps to be repeated. Finally, in today's multi-world era, the organization may have access to multiple clouds, and the AI user may need to learn different clouds APIs, which is a huge learning burden. So we see that there's a lot of cloud infra burden on the AI user. But these problems are equally applicable to the AI infra team or AI platform team, because these teams are responsible for building a system to solve all of these problems. Now, a second big challenge, of course, is cost. AI compute on the cloud is very, very expensive. There's actually quite a few reports talking about a large percentage of capital raised by AI companies are being spent on compute. And this problem of cost is only going to exacerbate because of today's GPU shortage, right? And that leads us to the third challenge, which is getting GPUs on the cloud. In fact, it has become so bad, so severe. Popular media outside of Silicon Valley have reported on this problem. And what does this all mean for an average AI user? Well, a couple days ago, I tried to get 8 A100 GPUs on the cloud. Actually, I tried 3 clouds. And on all 3 of them, I got some out-of-capacity errors that look something like this. So whenever these errors happen, the AI user has to waste valuable time by either waiting or trying to figure out which other region or cloud has the capacity. To solve all of these problems, we are building an open source system called SkyPilot, a system for running AI on any cloud. SkyPilot handles all of the previous cloud infra burden while saving significant cost and maximizing GPU availability. And it does so automatically. So here's how it works. The user submits a program to the system and a resource requirement. The resource requirement can be a high-level description, like the number or the type of GPUs. And we make no assumptions or restrictions about the program. So given this request, SkyPilot will figure out the best location, meaning the cheapest and the most valuable location to run the task. It will go ahead to provision a cluster, run the task in the cluster, and then finally automatically clean it up. So we are happy to say that when we released the system last year, we only supported these 3 hyperscalers, AWS, Azure, and Google. In the past couple of months, we've seen significant interest from the cloud providers. In fact, we are now supporting 7 and growing number of clouds. In particular, we support Oracle OCI, Lambda, which are 2 very popular clouds within the AI community. We also support IBM and Samsung, which are 2 hyperscaler clouds. And we call this collection of clouds the Sky ecosystem. And we want to enable users to transparently use them as easily as possible. And we are happy to work with the community to add more and more clouds. And we believe that will bring down the cost and improve the GPU availability. A quick word about the project status. SkyPilot is fully open source, available on GitHub. It can be quite easily installed using one command. In the past couple of months, we've gotten pretty good traction in terms of GitHub contributors, GitHub stars. But perhaps most exciting to us is that we are seeing tens of organizations adopt SkyPilot for their day-to-day work. So these include AI startups, AI companies, companies building products that integrate with SkyPilot, and also some top AI labs in academia. So what workloads are users running on SkyPilot? A major workload is, of course, AI training and serving. And they are doing it on both GPUs and TPUs. Users are also running CPU-intensive batch jobs. So these are like data cleaning, data processing of training data, high-performance computing, and so on. Perhaps most excitingly, we are seeing a lot of leading cutting-edge LLM projects adopt SkyPilot. For example, LLM's Vicuna project was trained and actually is being served using SkyPilot. It is the first open source chatbot with high quality. Also, Berkeley's vLLM project has taken the AI community by storm since a couple of months ago. And the vLLM team actually has written a very nice blog post talking about how they use SkyPilot to do all of their development. And they are actually here today to give a talk at 2:30 today, so we encourage everyone to check them out. Okay, so this is a quick overview of the system. Now I'm going to dive deeper into what are the core problems SkyPilot solves. Why use SkyPilot to run AI jobs? First, SkyPilot removes the cloud infra burden for the AI team. So imagine we are working on a typical ML project. We may have a project directory, working directory. We may have a setup script installing dependencies, and we may have a main program to run. Now, taking this project and running it through SkyPilot is super simple. We offer an intuitive YAML interface where users can specify these components. Additionally, the user declares the resource requirements, and we also give a very simple interface to mount an object storage bucket into the cluster. So what this means is that the user program can easily read data sets or write checkpoints to the bucket using a local path. And that's it. Using one command, users can launch this task to the cloud. And behind the scenes, SkyPilot takes care of all of the heavy lifting, such as picking out the best VM and location, provisioning reliable retries to guard against out-of-capacity errors, shipping the code and data to the cluster, and finally executing the task. Second, SkyPilot comes with an architecture that natively optimizes for lower costs. And here's how it works. So given a launch request, the first thing we do is to read from a catalog component. The catalog is simply a table recording all of the instance hardware details, their locations and their pricing, and we make sure the pricing is up to date. So from this catalog, we will filter a set of feasible offerings that satisfy this request. And it may look something like this table, including the cloud, the instance types, and the region and the pricing. Most recently, the community has added support for reserved instances. So what this means is that SkyPilot is smart enough to prioritize using these prepaid reserved instances over launching new ones. So we pass this set of candidates to an optimizer component, which is responsible for outputting the best location and instance. Now, importantly, during optimization, we will consider data versus compute locations. So if they are in different regions or in different clouds, we will make sure to calculate the data egress cost between them. And this output is then passed to a provisioner component, which is responsible for reliably provisioning a cluster. Once the cluster has been provisioned, we pass it to an executor backend. The backend will set up the cluster, run the task, and finally automatically cleans it up. SkyPilot's architecture also maximizes GPU availability in a native fashion. So to understand this, let's imagine we are an organization having access to AWS only. So on a launch request, what we would do is we will ask the optimizer for the cheapest region, and we will try to provision in that region. Now, if this region returns a capacity or a quota error, auto failover will kick in. Auto failover will try to re-optimize to get the next cheapest region, right? And so on and so forth. So we see that this auto failover mechanism really transparently handles all of the capacity or quota errors on behalf of the user. Now, let's say if our organization has access to multiple clouds, well, the same mechanism actually becomes more powerful, and the same mechanism applies. So what we do is we take all the regions organization has access to, and we sort them by price. So this picture here is showing a possible failover sequence utilizing 4 clouds. So as you can see here, we really believe this dramatically simplifies using multiple clouds. The more clouds you give to SkyPilot, the more powerful it becomes. Because if there's capacity anywhere in the search space, SkyPilot will automatically find it. Finally, we reduce costs even further by using a library inside SkyPilot called Managed Spot. So Spot instances are very cheap. As we all know, it's 3 to 6 times cheaper than on-demand. But the problem with them is they can get preempted at any time. So Managed Spot makes them feasible for AI jobs by offering automatic recovery. Here's how it works. Given a task, we will first connect to a user-specific Spot controller. The controller is simply a very cheap, small, on-demand virtual machines living in users' cloud account. Then this controller will start managing the entire life cycle of a Spot job. So for example, it may start by launching a Spot cluster in a GCP zone. It will then monitor the health of this cluster, and if it detects the cluster has been preempted, we will trigger a recovery procedure. And there are many possible scheduling policies here. For example, we can quickly back off from a congested region. And one thing to know here is this is something native solutions in cloud providers, something they cannot do because they cannot go beyond one region or one cloud. So as you can see here, throughout the lifetime of a single job, the same job can utilize more than one zone, region, and cloud. And this will improve the availability dramatically. Managed Spot has been especially useful for generative AI workloads because they use very expensive compute. For example, LLM's Vicuna LLM is very popular, and it actually used SkyPilot Managed Spot to fine-tune under $300. On the left, we are showing a real learning curve of the fine-tuning run, and you can see there are 3 segments here. And this means there are 2 automatic recoveries successfully performed by SkyPilot. On the right, you can find 2 URLs to some runnable examples, and you can reproduce this behavior. OK, so we have seen what SkyPilot can do today. Next, we are going to talk about what we are doing next. So SkyPilot, we are building SkyPilot to realize the vision of sky computing, which essentially means we want to enable applications to transparently use different clouds. We started with this simple goal, run AI on any cloud. But today, we are happy to say that we are significantly extending both of these axes. In terms of the location SkyPilot can run on, currently we support some hyperscalers and some AI clouds. Starting with this RIG's 0.4 release, we now support Kubernetes. What this means is that users can use the same friendly interface to submit jobs to both public clouds as well as their existing Kubernetes deployments. It also enables the seamless spillover to cloud VMs, right? If your Kubernetes cluster is congested, we will do the spillover for the user. We are very excited about this, so if you have a Kubernetes workload, we would love to chat with you. Now, in terms of the other axis, the workload being supported in SkyPilot, we currently focus on AI batch jobs. Today, we are now adding serving capabilities into SkyPilot. We are building SkyServe, a library inside SkyPilot that scales an existing AI framework, serving framework, and scales it across regions and clouds. So next, I'm going to spend a few slides talking about SkyServe. So why are we building SkyServe? If you look at a typical serving setup today, we may have some model replicas in a single region. These model replicas run on GPU machines. We may have a load balancer listening to user requests and routing them to the replicas. And let's say if our generative AI is super successful, we are seeing a lot of new traffic. This may trigger an auto-scaling event. However, due to today's GPU shortage, this region may fail to provide GPU capacity. When this happens, the new traffic will see degraded performance. So that's why we are building SkySurf. SkySurf utilizes multiple regions and clouds to solve this problem. It is conceptually very simple. It comes with a controller responsible for auto-scaling, and it comes with a single load balancing endpoint. So let's look at how it works. Let's say we triggered an auto-scaling event due to a lot of traffic. So different from before, we are going to use SkyPilot, SkyLaunch to bring up a new replica. Now, because of this, if the region A fails to provide capacity, SkyPilot will automatically fail over to the next cheapest region. So here we can succeed in bringing up a new replica in a region B. In the steady state, SkyPilot comes with an out-of-the-box load balancer. It will route all the requests to all the replicas, even if they are spread across regions and clouds. And finally, just like before, if your organization has access to multiple clouds, we can enable you to launch replicas on different clouds. And this improves the GPU availability, but it also brings down cost because lower cost AI clouds like Lambda can be used. We are happy to say that Chatbot Arena, which is a very popular website where users talk with different LLMs and compare their responses, they have been using SkySurf to serve their production traffic for quite a while. And using one command, Arena is able to bring up their entire deployment. And on the right, we are showing some replicas serving different models. And now I'm going to hand over to Wei Lin for a demo.
Thanks, Zhonghen. So yes, hi everyone, I'm Wei Lin. I'm a fourth year PhD student at Berkeley working on SkyPilot and also some of the LLMs projects like Vicuna and Chatbot Arena. So for the past few months, I've been fortunate to work with great people in the lab on the cutting-edge LLM efforts. We got like millions of model downloads on Hugging Face, and our demo website has served like millions of requests so far. So I'm going to share with you what I've learned so far and how we use SkyPilot to solve some of the challenges. And we believe these problems are relevant to industry people who are working on generative AI applications, and we hope to bring some insights to you. So just a quick summary on what I'm going to talk about. So there are a couple of challenges, as Zhonghen mentioned here, that we also met during the Vicuna development. So including the GPU scarcity and also reducing cost and then serving LLMs in real world. So yeah, and I'm going to give the demo on how SkyPilot solved them. So our story begins in March earlier this year, shortly after the release of Llama. And at that time, we were just about to see the progress that has been made for fine-tuning Llama. And we've just seen the early success of Stanford Alpaca project. And we wonder whether we can do better. So a bunch of PhD students in the lab team up together. And then we collect some high-quality dialogue data called shared GPT. And at that time, the space was like super competitive. Every day, there's a new model coming up. So we wonder if we can ship a better model, Chat Llama, as fast as we can in 2 weeks. So the first challenge we met is how to find a large enough GPU machine to fine-tune the 30 billion Llama model. So in our lab, the best GPU print is just V100. And it's not, it doesn't have enough memory, and it's not fast. And we didn't have time to waste. So we need the best options in the cloud, A100, which is A100 80 gigabytes then. And however, it turns out it's like super hard and then to search such kind of like expensive A100 in the cloud, which is a big issue as us and almost like a waste of our time. So, but fortunately, we knew this availability problem way before when we started to build SkyPilot. And the software set is ready to use. So let me show you how. And let me just move to my VS Code. So instead of going through all the complicated cloud catalog, here we can just type a simple command called skylaunch, and we specify the GPU type we want, which is a 180 GB here, and let's say I want 8 of them. So within a few seconds, it will return all the cloud regions with the exact resource requirement I specify and sorted by cost. So you can here you can see there are Lambda, there are Oracle Cloud, Azure, GCP, AWS. And trust me, if you try to do this yourself, you will spend hours instead and be overwhelmed by all the complicated cloud catalog and VM image you need to specify to launch your training job. So as we can see, the cheapest option now is Lambda. But at that time, we prefer to use GCP as we have cloud credits in the lab. And to do this is very simple. You can just specify --cloud GCP. And then we will only pick GCP regions and then search available A100 for you. So the good thing about SkyPilot is, oh, sorry, I typed the wrong button. Just give me one moment. Yes, here we go. So yeah, so as Zhongke mentioned, there's a GPU shortage right now we're all suffering from. And sometimes there may not be enough capacity in a certain region, right? So the great thing about SkyPilot is it will automatically fail over to regions that has capacity. And then here you can see first, SkyPilot is trying to launch the A100 instance in US Central 1A. And then you can see now it fails because there is no capacity. And then it will try to search the next one available for you. So this greatly helps us in reducing the time to get resources so we can focus on things that really matter. And moving on to the next challenge, which is reducing cost. We've done some small-scale experiments. It was successful. And now we are ready to train the real model, 30 billion llama on 300 million tokens, which takes about hundreds of hours, 800 hours, and it means probably 1,000 per experiment, which is a lot to us in a research lab. And our advisor has been telling us to reduce cost, to reduce spending. But how? It's again the very first problem we've been addressing since we built SkyPilot. So here is the I'm gonna do this wrong, and here's a simple command you can use to launch a cheaper A100 instance. Basically, use SPA instances. So as you can see before, it was like $40 per hour. So if you use SPA instances, will be 3x cheaper now, it becomes around 15. So this, and then we'll use SkyPilot. The SkyPilot will launch a job on the SPA instances. But you may be worried about the SPA preemption that could happen every few hours. So as Zhonghe mentioned, SkyPilot builds a system to automatically recover from preemption failures. And to use that feature, you just simply prepare some training, like a YAML config like this. So you specify some resources, you specify where you want to save your model checkpoint and data set, and also set up and run commands to launch your job. And that's it. So basically, with a very simple command like sky-spot launch, you can launch the training job easily, and no code change. Everything stays the same, except for SkyPilot does automatic recovery for you. And this greatly reduced our cost by 3x without sacrificing productivity. And now our advisor is happy. Yeah. So moving on to the next one, serving LLM in real world. So we launched Vicuna at the end of March, and it went viral. So our first tweet gathered millions of views, and then the demo website received hundreds of thousands of requests in a few days. So as we've been getting tractions, we started to think about how do we serve LLM at scale. So right now, the world is facing a GPU shortage, and we know there's no easy solution for multi-region serving, which motivates us to build SkyServe. So this is a simple system to scale your AI endpoint deployment across regions and cloud. And it's designed to be compatible with any AI serving framework you like, from vLLM, Triton, GGI, or Reserve. So, but instead giving you 10x better availability through multi-region and cloud. So I'm going to show you like how we use SkySurf for the chatbot arena website use case, in which we serve like 10 plus state-of-the-art LLMs for millions of requests so far. So let me just quickly show you what are the status look like, service status look like. So you can simply just type this command SkySurf status, and this is right. I just launched this service like yesterday. So you can see there are like 3 models here, ranging from 7 billion to 70 billion size, and they are like backed by different kind of GPUs depending on the model size. We use like GCP L4 to serve a smaller model, but we also use like more expensive one for bigger models, 33B and 70B. And you can see that it's multi-region, multi-cloud since day one to maximize availability. So like you can see, we use different regions in GCP, different cloud on Azure, so that to make sure that when we want to get machine, we can get it. And all the requests sent through this endpoint will be automatically load balanced to the different replicas you have. So for example, here we have 2 replicas for this Vicuna 7B model, and it will be automatically load balanced. The request sent to this endpoint will be automatically forward to one of these replicas. So do we still have time? 3 minutes. And then I will probably skip this, but basically these endpoints are just ready to use out of box. You can just fill in the endpoint IP here, and then send requests to it. Maybe we can try. Yeah. So and then the model is accepting requests and then return this for you, return the output for you. Yeah. So but how to launch this YAML? You may think. How to launch this service? You may think. So this is also with a very simple YAML you can specify. So basically just a bunch of resources requirement like we showed before, A100, and then the model you want to use, and they are like just some simple setup and run command for launching our services. But what's different is we introduce a new section called service, in which you need to specify the port that your service is served, and then also a readiness probe to let us know how to health check your service so that we can do fail recovery for you, and also the number of replicas. So with this, and then you can do SkySurf up, serve this YAML, and then we will try to search all the cloud regions that with this resources you specify for you, and then launch the service, do the load balancing. Yeah. So yeah, as someone mentioned, SkySurf has been powering the chatbot arena demo and served hundreds, thousands of requests so far. As we look forward, we are excited to bring more advanced deployment policy to SkySurf. So for example, spreading spot instances across region to avoid correlated preemption, or mix with on-demand and spot to give you more guarantee while saving cost. Yeah, so that's all for my demo. Thanks. I hope this makes sense. Thanks.
Cool. Thanks, Ray. OK, I'm going to skip this for time constraint, but this is Ray Summit. We use Ray. Ray is awesome. So this has been the technical part of the talk. So if you guys want to get involved, we've made it super easy. We put up a lot of resources online. We have a docs website, we have a technical blog, and we also have a Slack workspace. So we would love to talk with the community. And one thing to call out here is if you are an AI team trying to adopt SkyPilot, or if you're a cloud provider adding support for your cloud into the Sky ecosystem, please talk to us. The whole team is here to help you. OK, so 15 seconds. OK. SkyPilot, in summary, is a Sky computing system we've been building to run AI on any cloud. Now, because of this new approach, it delivers high cost savings, and it maximizes GPU availability automatically. In the long term, we want to build an open source infrastructure to really democratize Sky, meaning using multiple regions and multiple clouds. With that, thank you very much. We can take questions. No questions. Okay. Yeah.
You can take them in the hallway at your leisure.
Awesome. Okay.